In part 3, we're going to take a look at the sine, cosine, and tangent functions and how to use them in right triangles. So we started out with the general case that deals with all kinds of triangles, and now we're going to focus on specifically right triangles and some of their shortcuts. If we imagine the standard XY axis, so the standard coordinate plane, and on it we drew a triangle. So we have an angle, first of all, coming out of the center here. And let's call that angle theta. That's the typical name. And theta is just a Greek letter, kind of like an O with a line through it. And we draw this angle coming out, and this angle is coming from across here. And then we draw this straight up here. If we do this, we have created a right triangle. We're assuming we go straight up here. And this part going up we usually think of as y, and the part going across here we think of as x. And then this line right here, our hypotenuse of our triangle, we could call that C. Sometimes it's called R if you think of the radius coming out here. If we drew a circle around all of this, that would be our radius. But this here is going to be our triangle. I'm going to use x, y, and r for this example, but you could interchange other letters. What the function sine, cosine, and tangent do is allow you to create ratios of these sides to each other when describing that angle. And in particular, we're going to name our sides the opposite, adjacent, and hypotenuse compared to this angle right here. So compared to this angle, the hypotenuse is always going to be the longest side. So this is our hypotenuse. We also have our opposite side. So if you think of something that is opposite something, it's far away from it. If you sit opposite from someone, you sit across from them. So opposite is right there. And then finally, the last one is adjacent. And when things are adjacent, they are next to each other. So adjacent is going to be this side here, this x, because it's right next to the angle, it's touching the angle. Remember that opposite is generally pretty easy to remember because it's not touching the angle. Both hypotenuse and adjacent are. So you have to make sure that your hypotenuse is always your longest side right here, whereas your adjacent is the shorter side that is touching the angle. So now that we've relabeled this adjacent, opposite, and hypotenuse, we can set up a ratio for the sine, cosine, and tangent. And to help us remember this, we have this little thing, Sohcahtoa. And Sohcahtoa is just a memory technique, really. And what it stands for is the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. So if you remember Sohcahtoa and you write that out, you can figure out what your ratios are. So let's start with the sine. The sine, and we always remember that we're taking sines of an angle. You cannot just take a sine of thin air. You need to take the sine of an angle. Our angle is named theta. So sine of theta is equal to opposite over hypotenuse, which in this case, if we go back to our purple, would be y over r. As far as things for you to focus on, I want you to think about the opposite over hypotenuse and remember that. The y over r is not as important, but might be useful to reference in certain cases. Cosine of theta is adjacent over hypotenuse, so we would say adjacent over hypotenuse. And again, if we're using our purple letters here, that's going to be x over r. So the adjacent over the hypotenuse. And then finally, our tangent does not use the hypotenuse. It is opposite over adjacent. Or y over x. Another way to think of the tangent is actually the sine divided by the cosine. If you were to take sine divided by cosine, you would end up getting tangent. So we have our sine, cosine, and tangent functions. And the reason we want all three of them is, let's say that we have a triangle that only has two of the three pieces of information. Let's say we have a triangle here with our angle. It's a right triangle, and we know that this side is 4 and this side is 5. But we do not know what this side is right here. We could use just the 4 and the 5 to solve for theta. Now, of course, we could always use Pythagorean theorem and figure out that last side, but it's an extra step that we get to skip. If we know that opposite over hypotenuse is the sine function, we can use the fact that sine of theta is equal to 4 over 5. And we'll look at some examples of this. In this first example, we're told to find the tangent of x. So we're asked to find the tangent of angle x. Now the tangent, we remember, is going to be the opposite over adjacent. And so the opposite from angle x is going to be 20. And the adjacent is the side next to it that is not the hypotenuse. So the side next to it that's not the hypotenuse is going to be 21. So the tangent of x is equal to 20 over 21. And let's slide down here and just do number 6. We have a cosine here. So we are told to find the cosine of C. Cosine is the ratio that is adjacent over hypotenuse. And we know that because if we do Sohcahtoa, we know that cosine is adjacent over hypotenuse. So Sohcahtoa can help you remember these. Now adjacent, side next to it that's not the hypotenuse, is going to be 32. And then the hypotenuse is the longest side, which in this case is 40.